Hi, my name is James, and in this video I'm going to be deriving 5 Suvat equations which hopefully you'll find useful if you're studying mechanics in A-level maths or you're just struggling a bit with the kinematic side of physics. So first of all, we're going to start off with something quite intuitive, that the end velocity minus the initial velocity of an object is equal to its change in velocity, and that's also equal to acceleration times time. So for example, if an object was travelling initially at 50 meters per second and it took 10 seconds to reach 100 meters per second, then the change in velocity was 50 meters per second. It happened over a period of 10 seconds, and therefore we can say that the acceleration was 5 meters per second. So what we're going to do is just rearrange it by shifting the u over to the other side, and we have something that looks like v equals u plus at. So essentially the end velocity equals the initial velocity plus the change in that velocity. Our next three are going to involve working out the area under a velocity time graph. So we can start off with using the formula for an area of a trapezium, which is equal to its height times the length of its short and longer sides divided by 2. So what we can do is just sort of, we can flip this, actually no, we don't need to flip it, we can take it like it is, as a trapezium, and the height is its time, and the short and longer edges are u and v. So what we get is that the area is equal to time multiplied by u plus v over 2, and that's our first formula. S equals u plus v over 2 times time. Another way of working out the area under a velocity time graph is by separating this shape into a rectangle and a triangle. So the rectangle is just the height times base, which is ut, and then the area of the triangle is a half times height times base. So its base again is just t, but this time its height is v take away u. And we just derived v minus u equals at, so we can say this equals a half in brackets at multiplied by t again, which equals a half at squared. This gives us our third equation, which is s equals ut plus a half at squared. Another way of doing that by the same sort of method is we could take the area of the whole rectangle and then take away the small one, instead of doing a small rectangle and then adding on the triangle. So this big rectangle here is just v times t, and then we want to take away the area of the small triangle, which is still a half at squared. So an alternative way of writing that formula is s equals vt minus a half at squared. For our last formula, we just need to do a bit of rearranging, some algebra. So we know v equals u plus at. So what we can do is square both sides, and we get v squared equals, in brackets, u plus at squared. And when we expand this out, we get u squared plus 2u times at plus a squared t squared. So for this, we're just going to focus on this part momentarily, and we're going to take out a factor of 2a, and that leaves us with ut plus half at squared. Now, just a minute or two ago, we said that displacement or distance was equal to ut plus a half at squared, so collectively this term here simplifies down to 2as. And that's our last formula, v squared equals u squared plus 2as. That's all five formulas you're going to need to know for any mechanics or physics course at A-level study. I hope you found this video useful. If you do find these kind of things, deriving formulas, useful, you should check out my I equals NA video, or just look at my channel in general. Thank you very much for watching, and I'll see you in the next video.